You're in the session right now. Michigan Tech is going to be doing their student presentation. We've got 5 students here today. It's going to be Ryan Keene, Ruth Kirby, Logan May, Titus Lind, and Kevin Brockett. And they're going to be talking about their projects. But first, just wanted to make sure everyone's got their mobile phones, their phones silenced, so we're not getting any interruptions. And then I'm going to give you guys the code here. It's going to be A3, A2. A3, A2. All right, that's all I got. Ryan and Ruth, if you want to lead us off, please.
All right, good morning, everyone. This is our 25-26 projects for Michigan Technological University. So who are we? We are the Douglas Hohen Student Chapter of the National Society of Professional Surveyors. We're students in the Geospatial Engineering Department at Michigan Technological University, and we're involved in extracurricular geospatial projects. So the first project we did this year was a trip to Isle Royale National Park.
All right, for those who are unfamiliar with Isle Royale, here's a map. So we had most of our stuff over here on the top right of the screen called Maud Island. That is where the ranger station is. So we did a lot of dock profiles and utility stuff there. And I believe we had one day down here on the southwest part of the island called Wendigo. And our final day was up here on the top right called Rock Harbor. And we also had one project down here in Siskiwit Bay.
So our trip itinerary, the first day we just traveled. It is a 5.5, 6-hour boat ride out there, so there wasn't much time to do work afterwards. On Saturday, we started doing the docks around Mott Island, which is where we stayed, and our utility group did the utilities. We just did electrical utilities. On Sunday, we did the Wendigo docks and the Wendigo utilities, which is that southern part of the island. And on Monday, we did the Northeast Island docks. Tuesday, we kind of had a little bit of a break day, but we did the Rock Harbor docks and the utilities we finished up on Mott Island. And then on Wednesday, we returned to Michigan Tech.
All right, so we had 10 people travel across with us on the boat to the island. So half of us ended up doing a dock profile. So we used a Trimble R980 GPS receiver for that. And then 5 others did a electrical utility location on Mud Island and on Wendigo. And 7 of the 10 of us are here today. So if afterwards you have any additional questions, just reach out and let us know. All right, so how this project came to be. So about 1.5 years ago, Ruth here was curious if we could do anything extra fun for the club. So I had a alumni who works for the Park Service called Seth. I'm sorry, not Seth, someone who knew Seth. So he gave him my contact, and then Seth forwarded me over to Anthony or Tony. And then Tony is the person who's responsible for all the utility stuff and kind of the dock information. And then after a lot of communication, we ended up finalizing the trip after the first week of school, which was August 29th to September 3rd.
So the travel, we took the National Park Service, the Ranger 3. It was 5.5 hours in the water. The way there was pretty flat. It was a sunny day, but the way back it was very rough. It was probably at least 10-foot waves. It was pretty scary. But so a couple of the projects, well, we only did 2 projects. We did dock profiles across the island. So all the locations on the map that we showed you guys earlier, those are all locations that we did dock profiles. And then we did electrical and utility locating on both Mott Island and Wendigo using the Park Service like a utility locator, and then we used a Trimble GPS to shoot those in.
I'd like to add a funny note on the 2 slides ago. It was when we were on the boat, there would be a second where we would just see the sky, and then the next moment we would just see the water. So it was a little scary. All right, so this is what Ruth and I participated in, the dock profile. So the main objective of this was to see how much distance there was from the top of the water until the surface. That way we would know if boats would scrape the underbelly of their ship. So this is important for like some of the smaller docks. Like Tony contacted us and said, oh, this is a question I get all the time. Like, can I park my boat here? And he didn't really know an answer because he didn't know how deep the water was. So we had 5 roles. It was the data collector, the person with the rod, and if you're wondering what Jigman is, we had a unique contraption which had a tape measure with a chain attached to it. So what we would do is we would just drop it down into the water, and then we would be able to read the tape and see exactly how deep the water was. And then the rodman, we recorded the elevation of the water probably about 6 times for each dock, because theoretically it should be the same, but sometimes the water was pretty rocky, so it was a little more difficult to do that. And then we recorded the top of the dock and any times like it changed direction. And then we also had a crew that was out on the boat taking pictures from both above and below the water. And then going into detail with the utility location. So as I mentioned before, these were on Mud Island and on Wendigo. So the team would they would scan, and if they got a positive reading, they would mark it out with the GPS about every 50 feet or whenever it like had a turn. And then we would also mark all of the locations of the electrical boxes as well. And the jobs we had here was someone was going to use the utility locator, someone was taking notes, someone was using the equipment, and someone was taking photos. And we tried our best to rotate these roles so that everyone would have experience on them.
All right, so the deliverables. I drew scale CAD drawings of the 29 surveyed docks. I had CSV files with coordinates, elevations, and descriptions. I created an Excel file that contained the point data, depths at each dock, which I did like a calculator for, and then a pre-made future depth calculator for each dock. So they're able to, in the future, just put the average water elevation, and it will calculate if those water depths have changed based on how the water level changes. And then I did organized photos of each dock, and those are geo-referenced. For the utilities, I did scale drawings of the 2 surveyed areas, including multiple detailed sheets. We did CSV files containing coordinates, elevations, and descriptions, and organized photos of the utilities that were geo-referenced. So some fun things that we did around the islands. We got to see the northern lights from the docks. That was awesome. We saw tons of wildlife. One of our team members, he's not here today, but he saw a moose and a wolf. And no one else in our group did, so he just got really lucky. But we went on a couple hikes. We hiked up Mount Ojibwe to the lookout tower. We did the Stevens Point hike, which that's out of Rock Harbor if you just go north. And we got taken to the old fisheries around the island, Edison Fishery. And from there we walked to see the Moose Wolf Project, and that's where we saw all of these bones. So it was a really awesome experience. 9 out of 10 of us had never been to the island. I was the only one. So it was really cool to, not only go back to, but to give the other students the opportunity to go.
All right, so we will be back next year with about teams of 6. And some of the projects that we might do in the future are taking 3D LiDAR scans of historic locations like the Rock Harbor Lighthouse and other lighthouses across the island. Another thing we could do is trail mapping across the island. So this is something the National Park Service does have done, but they always appreciate having good data. And there were a few docks that we were not able to get to, mostly in Rock Harbor just because of time constraints. And we weren't able to do any of the utilities in Rock Harbor, just on Mud Island and Wendigo. And one last thing we could do is do an hydrographic underwater scanning, so we could attach a scanner to the front or the edge of a boat and just scan the surface under the water.
Yeah, and that would probably be especially helpful around some of those docks, probably the main ones. And we both just want to say thank you to Seiler, to Trimble for always providing us with the best equipment. We want to say thank you to both Anthony and Seth. They were a super big help. The National Park Service. Obviously, they were really generous with providing our students housing for those 5-6 days that we were on the island and free travel to the island. Does anyone have any questions?
Yes, sir.
How did you get between the different sites? I mean, I've been there, it's a long walk from one end to the other.
Yes, so thankfully Tony had access to a boat, so like all 10 of us would just ride on the boat around the water to each of the docks. Yep.
Yes.
Did you forget any gear that you got there? Oh no, we should have brought that.
Actually, no, we had too much gear.
Yeah.
So like we had an entire like cart full of gear, but we ended up just using the GPS receivers. Like we had total stations too. Exactly.
Yeah.
Yeah.
What's the Park Service do with your deliverables? Are they integrating that in this existing drawings they have?
So I'm still working with Tony a little bit on this. We're trying to find a good way to present the data to the public, which he's talking with me about like finding a grant so he can pay me to keep pursuing this and finding a better like I guess interface to do it on. But hopefully they'll at least post the depths from this year that way people can know around average what the dock depths are.
Where the docks are, any plans to set gauges there to let them know where the elevations are?
Yes, Tony talked about doing that. So
Yes, sir.
On the ride back, did anyone get motion sickness?
I have a little funny story. So like right away, right away I was completely fine, but when I was like showering at night, I felt like I was moving around.
yeah.
But,
For like 2 days after, I like told Ryan, I'm like, I still feel like this morning, like I'm going like that.
I don't think anyone threw up from our group, but
No.
no.
Yeah,
But-
we were.
Yeah. Yes, sir.
Question, did you meet Tony's moose?
No.
He has a pet moose. Did he tell you about that?
He did a little bit, but no, we did not. Anyone else?
Yeah. Any further questions?
All right.
All right. Thank you
Thank
very
you.
much.
All right, I'm Logan May, and for our surveying and or 3D scanning and LiDAR class, my project was to do a 3D scan of the Houghton Portage Lake Lift Bridge. So we decided that we wanted to use the X7 Trimble scanner. Our professor had a little problem with that. He didn't want us walking on top of the bridge, which we really wanted to do. So we decided to go with our backup plan and use the SX12 scanner and do it from a distance, which was really nice. As you can see here in our photo on the right, we had a couple stations, about 4 on each side, and then a few on top overlooking the bridge. That way we were out of traffic and we could continue with our project. Our professor was very stickler about us not getting hit by cars. It would have been kind of funny though. Well, not really, but it would have been funny. So we had about, let's go back here. Our control stations on the right using the SX12 was really nice because it's a total station and it's a scanner. So we did a little, our grid here, control point 1, you can see somewhere right there. That's where we originally set up, realized it was a bad location, moved to control point 2, and then we just continued to backsite across the edges here, across the channel. so that we could get a complete picture from each side. So this is what it looks like. Started at point 1 here, did a little traversed point 2, and then we went to point 3. Point 3 would backside either point 1 or 2 or 5. Actually, I don't know if we could backside point 5. But using the SX12, it's already referenced. If you do a little traverse, you can have it referenced to each other, which was really nice. Because we wanted to use the SX12 with the auto registration, except that doesn't get distance very well. So then SX12 with this, we did have to, what am I trying to say here? We did have to do a traverse so that all these points could be registered with each other instead of doing it manually the hard way. So continue here. Actually, I'll go back. Right here, we have one scan that is so far away from everything that we couldn't see any of our control points. So that when we did have to go in, the only point that did not have registration already tied in with each other was that one up on top overlooking the bridge. So we did have to go through manually in TBC and adjust our point cloud. We had to pick 3 points to register, to do auto registration here. You can see here in the bottom right, we got to pick some pairs. That was kind of hard. The SX12 from a distance, it does pick it up very well, but to do a very dense point cloud, you can kind of see right here. It looks good, but when you zoom in real close, it kind of leaves some features out. We could have gotten it a lot better, but then our time constraints limited it to us about 2 hours of scanning per day we went out. So we didn't do very long scans. I think we did about 10 minutes per scan. And with the SX12, it's really nice if you have the little controller, the little tablet, you can cut out your area of where you want to scan so that we didn't have to pick up a billion points in the background, like on the side of the docks that it would pick up or something like that. We could cut out just a little shape of the bridge and say, we just want this area to get scanned, which cut down a lot on the time of each scan. So the pitfalls were probably really hard for us. I mean, we experienced a lot. Overlap in registration, we did have a little problem sometimes, just because they're so far away and from different sides. We really wanted to use the X7. It would have made registration really nice, but again, it's got a distance problem. Picks up really nice when you're within, I think it's 200 feet. Maybe it's a little longer than that you can pick up, but it only pick up parts of the bridge, wouldn't do so very well. The other problem was the Ranger 3 was still operating at this time because we did this in the early fall. And it's a lift bridge, so the bridge likes to move a lot, which one of the days we had a whole day completely scrapped. They raised the bridge, as you can see here in the photo, and then normally they put it down to like right here, that bottom level, that's brick or grates. They usually leave above, so you have this little area right here that you can drive your little boat under. But they decided that day that they were going to drop the bridge all the way down to the water level. So most of our scans had it with the bridge at normal level, upper level, driving on the grates. So we lost a whole day of scanning for that. Sight lines was a problem. We usually had to shoot across. Usually we're standing over there. We had to shoot all the way over here with our traverse. You know, we're shooting 200 or 2,000 feet or so. Trying to shoot about a half a mile, trying to shoot across the channel. Sometimes it didn't work out so well. We had to really try to find good areas to see. And then colorizing these photos was a little problem. Some days it was sunny, some days it was very cloudy. So then when we were colorizing them, some areas would be very bright, some areas would be very dull. We wish we could have done this in all one day, but we did have to travel across the water. It was kind of funny. One group would be with the scanner, and one group would be at the back site, and we'd be on opposite sides, and then we have to do a complete flip, and then we got to go here, and it takes about 15 minutes of time. You got to get out on the road, cross Highway 41, across the bridge, set up, reset up, and then by the time we do the scan, we'd get about 2 to 3 scans in about 2 hours. So it took us quite a while to do all these scans. What do I want to show here? So yeah, you can see these lines are about a half a mile across. and it takes a while to get on this bridge, especially in the morning when we did these, about between 8 and 10 a.m. Traffic's pretty heavy at this point. And doing the Uper loop kind of takes a minute to loop yourself all the way around. But that was our project for surveying in LiDAR scanning class. Does anyone have any questions about this? Yes?
How long were you looking at once you actually got the scanner set up?
Scanner setup, it's about 10 minutes. I mean,
First scan?
yeah, with the tool that you can cut out where you want to scan, it saved us a lot of time, but we did want to do high resolution because we're far distance away. I mean, from the photo down here on the right, we're still 300 feet from the bridge, you know? It looks kind of deceiving, but we're still pretty far away. Just so we could, if we get too close to the bridge, we didn't really have a backsite we could shoot across to. And we did like to do our backsites across from each other, across the bridge. Kind of kitty corner to each other, so it would get longer distance for a backsite. Yes?
Did you have any ground tested control on either abutment? Or
Did-
just all between the control points away from the
Just all between the control points on the bridge. We didn't really tie into anything. We didn't geo-reference this at all. It was just, we just ran ourselves a little traverse so that the scans would be able to tie into each other a lot better. And then if we wanted geo-reference it, it'd be really easy because we did set up 1 or 2 control points. I think we put control points down, just a little rebar rod, a little cap on it, so we could always come back and geo-reference it to precision if we needed to. Yes?
Do you have an end user for this project?
No, we just did this for our class. We needed to do a LiDAR scan of something, and instead of doing like our Husky statue or a little building, we decided to go big and do the whole bridge. And right here is kind of how it turned out. We cut out all the unnecessary data, and it looks pretty good from a distance, but as you can see right there, we couldn't get on top of the bridge or get in very good, so a lot of the roadway and a lot of the real minute details are missing. Any other questions?
I just have,
Yeah.
I'm Dave Bowerman from MDOT. We did a fully controlled scan of both decks, probably about 6 weeks before you did yours. And it'd be nice to get that data and we could just kind of partner together and
Yeah.
play around with the 2 scans and see how they compare.
Yeah, we'd love to give that to you. Were you doing, what time of day were you doing it? Or what, like day, month?
It was August, just before classes started.
Okay, did you come sometime in like October?
We haven't been there, but the design team has been back.
Okay, it was your design team that kind of screwed us up a little bit. Just saying, because when the Ranger 3 went through, they lowered the bridge, and then MDOT was on the bridge the entire day. So you kind of took us for a doozy there, because we're like, what? We thought MDOT was done with all their projects. So yeah, you guys were checking out, looking at the top of the bridge deck. Yeah, kind of messed up a whole day of scanning for us. We had to come back on a Sunday and do about 5 hours worth of work. I don't want to work on Sundays. Any work? Yes.
So I'm curious on that. Were you talking to the lift masters at all? Was there any communication as far as scheduling and whether these guys were going to be there when?
We did not. We thought since we were so far away, well, let me go back here. We thought since we were off the bridge and it would take too much coordination, and if we did want to coordinate, we would have done more. Like the top of the bridge, took the X7 on top and got a lot more details. But we just kind of wanted an outline of the bridge. If we did, our professor kind of limited us on actually going on the bridge, so we had to stay quite far away. But if we did, we thought about it. It's what we originally wanted to do, is do a big whole thing and actually get really good data on it. But again, we were limited on what we could do. Yeah.
So different question. When you were scanning, did you mess with the density based on there were certain control points that were further away?
We did.
increase your density for certain things?
Yes. Ex- Especially control point 2. It's so far away. We really had to zoom in and then cut out. We cut out our areas where we wanted to scan so that we could increase the density and reduce our time. Because if we did a whole scan, like with the tuned up density, we'd be getting like the buildings over here and the buildings over here. So with the cutout feature, you can pick what you want. We can just crank the density on it and get really good data from a distance. Plus, we had to if we wanted to see anything with somewhat of a good detail from so far away. Any more questions? Nope. All right. Well, thank you.
Hello, I'm Titus Lind. I'm a senior at Michigan Tech, and one of my projects that I wanted to do, this wasn't for a class or anything, I just wanted to do it. So I scanned the SS City of Milwaukee and USCGC Acacia. It's in my hometown, the city of Milwaukee. It's a National Historic Landmark. It's old Great Lakes car ferry. It's about 350 feet long. I use the Trimble X7 scanner. I brought that home over one of the breaks. I took about 52 setups, and I scanned what I could from the dock and then the ground around the ship. This is basically what I could do, and it was kind of hard because, as you can see here, all of that I wasn't able to scan because there's nowhere to set up because this is a lake right here. So my goal is to, over hopefully this coming spring break, when I go home, I want to take the scanner, and hopefully there's a nice sheet of ice on the lake where I could walk out, set up the scanner, and then scan the bow of the ship, depending on how thick the ice is. If not, I might take the total station scanner, because then I could set up on this dock down here, and I would be able to shoot and collect the bow of the ship up until kind of where it curves in right there. We've already, there wasn't really a kind of deliverables that we really needed because I just wanted to do this, but once I scanned it, then I was actually finding some good useful things that we were actually using the data for. I am a board member for the nonprofit of the ship, so that's kind of why I have the interest in doing it. But if you look closely, there's a bunch of basic guide wires up on all these smokestacks and up on the masts. And we are looking into some renovation projects, and one of the projects we were thinking about doing would be replacing all those wires and calculating how we would calculate the length of all those wires. There's probably about 30 to 40 wires total. That probably would have been decently hard to do without the scan data, but then I uploaded it in Trimble Business Center and just used the measuring tool. And I was able to measure all the lengths of the wires, and then I could come up with a rough total length that we would either need to buy if we were to replace the wires. We're also looking at doing some work on the stacks, and we didn't really have a design of how big they were, how tall they were, the diameter of them. So pulling it up in Trimble Business Center, I was able to then use the measuring tool, and it was very simple to find those dimensions, and also just historic preservation. It would be cool if I can finish the rest of the scan, then we could make 3D models. A little Easter egg right down here, that right there, that's actually like a 10-foot skeleton. During October, we turned the ship into a big haunted house. So on some of the other scans, you can see a huge skeleton standing right there, and then there's like another cage hanging from the ceiling with a skeleton in it there. So a little Easter egg. I would probably edit those out if I was to publish this model or something like that. But yeah, that's the main project for this. But then my main project that I did for this was the MTU Winter Carnival snow statues scannings. As everyone knows, we get a lot of snow at Michigan Tech, and the one thing that we like to do is make statues with the snow. So this one here on the right, this was the first place statue scan. As you can see, this is about as tall as this 3-story building right here. It took about 12 scans to use. We had someone from Trimble, they wanted to, or Seiler, they wanted to come up and bring the scanner for us before we were using a Faro scanner, and it worked well, but with this X12 laser scanner, it was able to self-register all the points, or each scan together while we were in the field. So then when we went into the office, we didn't have to spend, usually in previous years, it'd be about an hour for having the processes register the scans together. So we took, this was for the first place statue, Phi Kappa Tau. We took 12 instrument setups. Each of those different colors is a different setup we did around the statue. We used the X12 laser scanner, and we did about 45-second scan durations. Next year, if we use the X12 again, I would probably double or triple that scan duration. The scans turned out really well, but with the detail that we've done in the past, the 45-second scans weren't quite as good as I would have liked. And given that the scanner wasn't ours, once I kind of realized that the scans weren't complete, the scanner was already back down in Lansing, so we couldn't really scan more. And also, it started melting, so it was a bit warm the week after. If you all have your phones, you can actually scan that QR code, and it will take you to Sketchfab, and you can view the 2 scans that we did. Or you can just type in Sketchfab on your phone and just type in MTU Winter Carnival 2026. And there's 2 scans that we did for this year. But yeah, here is the finished scan. It's not as complete as I would have liked, but it's still very detailed, and the amount of points were in this mesh. It was, I think it's about 8 million triangles that actually formed the mesh itself. We took the data, we put it into Trimble Business Center, and I was able to delete all the points I didn't want, and I could use the I could basically have it pick out all the people around the statues, so I could just then delete the people from those class points. And that made it easier because processing this in reality capture to actually make the model itself, that if you wanted to delete people, you kind of had to do a top-down view and then circle them, but then it would leave a hole in the bottom of the model. And then once you filled that hole, it would just be a white line or circle, and it wouldn't have the details of the ground and stuff. But using Trimble Business Center to delete the people, it would just basically delete up or down to their feet, and you wouldn't have that circle hole on the bottom of the mesh. Yeah, we put it into reality capture, and that actually makes the 3D mesh, and it gives it the bottom and the shape, or the bottom of kind of the base of it, and you could put that in 3D printer, and you could print it if you want. Next year, our goal is to actually print out some of them and then sell them at our booth here, and also sell them to the frats that make them, because they put in like 40 hours a week, and I'm sure they would pay a hefty penny to have a model sitting on their desk of what all that work they put into. And then Kevin used, or he can talk about this, but he used the Faro scanner. Do you want to talk? For some of the other snow statues on campus.
Hi everyone, my name's Kevin. I'm a graduate student at Michigan Tech, and as has been mentioned, we're really fortunate there to have the support of Seiler especially through all the equipment that they lend our program, so that we always have the latest and greatest stuff. And for Winter Carnival, Mark with Siler came up and brought his X12, and that's all this stuff that Titus has been showing you. Turned out really well. It was a lot of fun to work with. However, our department also owns a Faro 3D scanner that we've had for a while, so I thought it would be fun to use that as well during this Winter Carnival. And my ultimate goal was to get a couple of sculptures captured and then render them as 3D printed models to scale. You might notice I'm not holding one. The reason for that is that Winter Carnival was 2 weeks ago, and last week I came down with the flu that made it really hard to do anything other than lie very still for a few days. So it didn't quite meet the timeline. I did process all the data for the Faro scans, and all that nice clean data is currently on a thumb drive on my kitchen table back in Houghton. So I don't have that to show either, unfortunately. But it did work out really well. We used to have a legacy version of the Faro software scene. That hasn't worked recently due to some licensing issues we've had with our computer at the department. However, the Faro scans will come right into Trimble Business Center, which made it really easy to work with those and clean them up. So the Space Moose was my favorite sculpture. That's why I scanned that one. And then the Futurama scene was also really elaborate display that I thought was pretty cool. The only issue I had was when I scanned the Space Moose statue, I didn't have enough overlap, so one of the 3 scans didn't auto-register correctly, but fortunately, pairwise registration brought it all together. And then for all the different scans that I did on the Futurama scene, they auto-registered great because there was a building right behind them, so it automatically registered the plane of the building face very easily. So that was fun to work with, and hopefully next year I'll actually have something a little more impressive than just an idea to tell you about. Do we have any more slides on that?
No.
Okay, so does anyone have any questions about the Winter Carnival scanning?
Yeah.
I got a question for you. You mentioned about getting your 3D scans of the ice sculptures into a 3D model and a 3D printer. How about the ship? Is there an end result to get that into a 3D printer?
If I can finish the front of it, that would be the goal, to make the little 3D models, but it all depends on if there's ice back home. Yeah. Any other questions?
All right, thank you very much. Okay, thanks again to Siler for supporting our program and to everyone else.
There is also for, yeah, keep going. Ryan's gonna talk about this.
All right, this is the final announcement. I am pleased to tell you that Michigan Tech will finally be attending the MSPS competition this year, I believe after 9 years. So I'd appreciate it if you guys would like to. Yeah. So I'd appreciate it if you guys would donate. You could talk to me or anyone from Michigan Tech here, and thank you very much for coming.